Industrial garment manufacturing operates at a blistering pace. At thousands of stitches per minute, a single mechanical miscalibration multiplies into a cascade of failed units before the operator can hit the stop button. We are looking at a pre-wash quality audit conducted at Shazeb Washing and Dyeing. The target is incoming denim style number 112388323. This document shows the incoming inspection results from manufacturing unit CGL02. The auditors caught a massive 10.8% overall defect rate. In the quantitative breakdown, 27 pieces were pulled, categorized by type and scale, ranging from medium-level raw material flaws to high-severity structural issues. A failure rate this high is never random. Every frayed edge or skipped stitch serves as a precise statistical symptom of a failing system on the factory floor. To correct the system, we use a specific operational framework. We trace each physical flaw back to its root cause analysis, or RCA, and then mandate a corrective and preventive action, a CAPA, to stop it from recurring. Catching this at the pre-wash gate is vital. If these 27 units proceed into the chemical wash cycle, their structural weaknesses and color variances will lock permanently into the denim, resulting in an unrecoverable total loss. The highest frequency error in this audit accounts for nearly half the total defects. It falls under structural sewing construction, categorized specifically as sewing looseness. Here is how that flaw physically manifests. Notice the slack, detached stitch loops sitting loosely on top of the waistband and front fly seams instead of binding the layers of fabric together. The root cause here is mechanical. Before running heavy plies of denim, the machine operator failed to check their stitches per inch, or SPI, gauge. Improper thread tensioning means the loose bobbin or needle tension discs lack the friction required to pull the final stitch tight against the fabric. The mandated corrective action requires factory management to enforce strict mechanical tension calibration at the start of every single shift. The second mechanical failure accounts for 0.8% of the total defects, identified in the report as raw edge out. Looking at this sample, you can see uncut and unserged raw fabric fringes slipping completely outside the joined seam margins, leaving exposed threads right near the zipper base. This defect appears again protruding from this curved pocket stitch, confirming it is a systemic line failure rather than a one-off anomaly. The root cause traces back to operators feeding seam allowances inaccurately. This is compounded by dull trimming blades on the overlock machines failing to cleanly sever the excess material. To correct this, all assembly line sewing machines must be equipped with rigid mechanical edge guides, and the trimming knives need immediate replacement across the board. Mechanical defects are mathematical inevitabilities. Without rigid physical guides and sharp blades in place, even an experienced operator will consistently produce failed margins. We move away from machine calibration to address human procedural errors, beginning upstream on the cutting room floor. The auditors flagged a high-severity tonal mismatch issue known as part shading. Looking at the panels indicated by the red arrow, there is a stark color variance separating the left and right legs. This exact procedural error also manifests on smaller attached components, resulting in pocket shading. Here, the back pocket shows a noticeably different indigo saturation compared to the main panel it rests on. The root cause originates during the bundle sorting phase. Cutting room operators are cross-mixing pattern parts pulled from entirely different fabric rolls. To permanently eliminate shading, the factory must enforce strict numbering ticket control. Every single component of one garment must originate from the exact same roll lay. Transitioning down the assembly line, we find a critical instance of operator negligence, the missing bar tack defect. Bar tacks provide essential structural support at a garment's inner stress points. Here, the bare inner stitching shows a complete absence of that required reinforcement. The root cause is deliberate. Operators are skipping the bar tack assembly station entirely to keep pace with high-speed production quotas. The mandate requires a 100% end-of-line check specifically for bar tacks. This enforces strict adherence to the factory's standard operating procedure, or SOP. Human errors require rigid systemic guardrails. Strict numbering protocols and unyielding SOP enforcement are the only reliable ways to idiot-proof the chaotic environment of a high-speed assembly line. The final defect categories bypass the sewing machines entirely. They point directly to upstream raw material inspection failures and extreme instances of mishandling. Here is the visual evidence of upstream fabric faults. Notice the irregular yarn slubs, weft breaks, and this prominent raised yarn knot embedded right on the face of the denim weave. The root cause is a failure at the warehouse level to conduct an adequate 4-point raw material inspection prior to the spreading and cutting phase. As an immediate corrective action, quality control must actively flag these fabric flaws with bright stickering during spreading. This ensures pattern cutters know exactly where to avoid defective zones. Finally, we reach the single most severe classification of defect found in the entire lot, the critical reject. Look closely at this physical puncture. The severed threads adjacent to the waistband seam force a complete rejection of the garment. Direct fiber damage to heavy textiles is visceral and irreversible. Operationally, this is caused by improper handling of thread snips and blunt scissors, or a direct laceration from the machine's feed dog. A 0.4% critical defect rate might seem statistically small, but physical punctures bypass all rework options. They represent an absolute permanent loss of raw material, time, and labor. We step back from the microanalysis of individual defects to address the macro strategy required to fix the CGL-02 manufacturing unit. The auditor's report dictates a final summary matrix outlining immediate factory directives. The absolute first directive: all 27 defective pieces must be actively quarantined. The core timeline constraint is strict. These pieces must be shipped back to CGL-02 for immediate rework before a single pair enters the washing facility. To prevent recurrence, the factory must execute a 3-pillar intervention: conduct sequential cutting audits, implement hourly tension calibration, and enforce end-of-line SOPs. A deconstructed quality audit provides a precise operational map, diagnosing the exact points where the manufacturing system is bleeding efficiency.